O.R.S. is an acronym for the Orbital River Station. With signal orange and white, it takes the form of a giant life-saving ring. It was first anchored in summer 2019 in the middle of the River Rhone in Avignon, where the strong current made it rotate. The revolving of O.R.S. renders the speed and force of the river current immediately perceptible. Inspired by utopian concepts for space habitation, which take the form of a slowly turning giant torus, O.R.S. is an earthbound vehicle that could be used to generate energy. As a project, it is an open-air artistic laboratory for environmental science practice, a form of floating architecture. To realise the orbital movement of O.R.S., we made many models of various forms, some of which were tested in the fluid dynamics laboratory inside a long aquarium equipped with a current simulator. After several failures using fixed blade prototypes, we conceived a dynamic form, a textile pocket that has the ability to change shape as the ring rotates. The pouches open and close under the water, moving both with and against the current simultaneously in a dynamic play of shapes. The textile paddles helped determine the choice of material and the final design for the inflatable sculpture. While deployed in the River Rhone, we attached and immersed a new material called covalent organic frameworks, or COF. These sensors, made at the Iberian International Nanotechnology Institute, capture lipophilic organic pollutants by trapping molecules inside nanoscale pores. Back at the lab, the sensors were photographed with an electron microscope where diatom fossils are visible in a landscape of debris. Chemical analysis revealed significant amounts of ibuprofen, diclofenac, and topiramate, 3 common pharmaceuticals, as well as the pesticide chlorpyrifos. The COF was then pressed into a form to be worn on a finger. The little O.R.S. is a proof of concept, a small gesture, to counteract pharmaceutical contamination when swimming. The research continued in the loops of the River Seine as we began fishing for contaminated water. Samples were collected and used to make a map to visualize the presence of sulfide, a dissolved form of sulfur, a contaminant caused by industrial activity. The map was made by giving new form to a paper-based sensor invented at ENL. We designed and printed maps in solid wax ink, heating the paper so that the wax ink soaks all the way through. A nanogold solution was made and applied to the white parts of the paper. This white area, the sensor, is the river. When the paper absorbs 1 drop of river water, high levels of sulfide will make the green fluorescence less visible. The map of the river is made from the actual water of the Seine and made visible through the presence or absence of sulfide contamination.